BMTC 131 Calculus Block 1 Essential Preliminary Concept Course Introduction Block Introduction Notation and Symbol Unit 1 Sets and Operations on them Unit 2 Functions Unit 5 Unit 3 2D coordinate systems Unit 4 complex numbers Unit 5 polynomial equations and their solutions miscellaneous exercises course introduction. This is the first mathematics course you will be studying in the bachelor's degree program. The aim of this course is to develop an understanding of basic mathematical concepts and techniques that you will require for studying other mathematics courses of the program, as well as any further study and work you undertake in mathematics. Calculus is divided into two broad areas, differential calculus and integral calculus. Broadly speaking, differential calculus is the study of change and integral calculus is about adding up the parts. Differential calculus helps you to find, for example, the effect of changing condition on a system being investigated and hence to gain control over the system. The process of this mathematical investigation uses the powerful techniques of modeling and phenomena concerned. The models usually involve differential equations. Differential calculus is useful in formulating model and integral calculus used to solve the differential equations associated with the model. Apart from well-known applications in physics, mathematical models based on calculus are used for the study of population ecology, cybernetics, management practices, economics, and medicine. In this course, we shall focus on integral calculus after we discuss differential calculus. However, it was integral calculus that developed first historically. This has its origin in the need for measuring lands for the purpose of revenue collection. It is said that the Egyptian river Nile changed its course often and the land near it, when differently carved boundaries were required to be measured again and again for levying taxes. This led to the development of mensuration in the Egyptian civilization. We can regard mensuration as the forerunner of integral calculus. Indeed, one meaning of the word quadrature used in integration is computing the area. The modern development of calculus began with the work of the famous 17th century mathematicians Newton and Leibniz. In developing differential calculus, one of the early successes of calculus was the prediction of the period of Halley's comet. As you can see, calculus provides a powerful tool for the study of not only such natural phenomenon but also artificial entities like the stock markets. Over the centuries, many European mathematicians like Euler, Lagrange, the Bernoullis, Gauss, Cauchy, and Riemann contributed to the development of this subject. Now, a few words about how this course unfolds. In the first block of this course, you will be introduced to two basic building blocks of mathematics, namely sets and functions. In the processes, you would recall a lot of related mathematics you studied in school, including two important coordinate systems for representing and studying two-dimensional spaces. Next, you will get more than a glimpse of the world of complex numbers, C. Finally, you will study ways of solving certain polynomial equations over R. In the second block, you will begin by studying and properties of real numbers that you will need again and again. You will also study concept of limits and continuity, which play a central role in calculus and more generally in mathematics. In the third block, you will begin your study of differential calculus with the definition of a derivative and its basic properties. You will study several formulas for the derivatives of some functions which are used often, like polynomial functions and trigonometric functions. This block ends with a discussion on higher order derivatives and the Leibniz rule for finding higher order derivatives. In the fourth block, you will find some applications of differentiations. You shall study how derivatives can help to get information about various geometrical properties of curves. The block ends with the discussions on the tracing of different types of curves. In the fifth, the last block, your focus will be on integral calculus. You will study concept of integral of a function and primitive of a function. You will also study the integrals of common functions like polynomial functions and trigonometric functions. You will get an opportunity to apply some techniques of integration like the substitution method, integration by parts, and reduction formula. The block ends with some applications of integral calculus for measuring lengths and areas and volumes. Now a word about our notations. Each block has units and each unit is divided into sections, which may be further divided into subsections. These sections or subsections are numbered sequentially. As are the exercises and important equations in a unit, since the material in the different units is heavily interlinked, there will be a lot of cross-reference. For this, we will be using the notation section xy to mean section y of unit x. Throughout this course, the emphasis will be on techniques rather than on memory, so you may not find many proofs there. You will be able to find the proofs of many of the theorems you study and apply here in our third semester course, Real Analysis. Another compulsory component of this course is its assignment, which covers the whole course. Your academic counselor at the study center will evaluate it and return it to you with detailed comment. Thus, the assignment is meant to be a teaching as well as an assessment aid. Further, you will not be allowed to take the exam of this course till you submit your assignment response at your study center. So please submit it well in time. The course material that we have sent you is self-sufficient. If you have a problem in understanding any portion, please ask your academic counselor for help. Also, if you feel like studying any topic in greater depth, you may consult. A word of friendly advice here is that to learn the various techniques presented in the course, you will need to put in a lot of practice in solving problems given in the materials. You should attempt to solve all the exercises in the blocks as you go along. Before you look up the solution, as a part of the tutorials, we have added miscellaneous examples and exercises at the end of each block. You should also attempt these exercises in addition. You may also like to look up some other books in the library of your study center and try to solve some exercises from these books. Some useful books and websites are the following. One Essential Calculus by James Stewart, Cengage publication. To Calculus by Anton Vivenson Davis, Wiley publication. Brilliant.org sites, Math is Fun sites, math.mit.edu sites. We have also prepared a video program which will be available at your study center called Limits based on the material in block 2. Wishing you a happy learning experience. The course team.